Hello everyone. Let us start with the long awaited lecture on monsoon. I shall be using this PowerPoint as well as the website earth.nullschool.net to explain about the monsoon. So, this term monsoon is used for seasonally reversing winds. So, whenever people ask what do you understand by monsoon? You should simply say that monsoon is the seasonal reversal of the wind pattern, or they are seasonally reversing winds. There are several origins, debated origins of this word. Few people say that it has been derived from the Arabic word mosim. Others say it is a Malayan word monism. Some people say it is a Portuguese word Monaco. Dutch say it is a original word monsoon. So basically, all these words they have been used to denote the weather patterns. And these winds they reverse their direction every 6 months. The term monsoon signifies the directional shifting of winds from one season to other. So, if it is the summer season, then warm and moist winds which blow from the ocean towards land, while cold and dry winds they originate on land and blow seaward. Now, the original usage of this term monsoon was to signify the surface winds of southern Asia. But now the term monsoon is applied to a whole series of different phenomena: the stratospheric monsoon, European monsoon, the Malayan monsoon, etc. But strictly speaking, the term monsoon is better suited once you use it for the Asian uh, landmass or Asian region, and in particular, the Indian monsoon is the very significant one. So, in this lecture, we shall be discussing the uh, East Asian monsoon, compare it with South Asian monsoon, and then in detail we shall discuss the mechanism and concepts for the Indian monsoon. Now, another important thing over here is that the word monsoon is used only for the wind systems where the seasonal reversal exceeds 120 degrees of wind change with the change of season. So, almost there is a complete reversal of wind pattern, then only they will be considered as the monsoon. So, in the tropical region, in the tropics, during the winter season, the winds they go from northeast towards southwest, means they are the northeasterly winds, while during the summer season the direction reverses and these winds they become southwesterly winds and they blow from southwest to northeast. So we can see here the seasonal reversal is more than 120 degrees. The tropical region mentioned over here in this map, it includes the parts of the East Asian region, the Indonesian region, the Central African region, the Northern Australian region. So all these they are impacted by these monsoonal winds. So to begin with the Asian monsoon circulation, we should understand that the winds are the result of pressure differences. So, winds they blow from high pressure to low pressure. This concept will be used all across. Second, the pressure is a direct result of temperature. So, high temperature causes low pressure, and likewise, low temperature leads to high pressure. I have discussed this in detail in my lecture on the air pressure. So, the whole idea to show you this map is that the Asian monsoon circulation is impacted by the pressure, the temperature, and then a very important factor is the vastness, vastness of the Asian continent. It is so large. See the area, it's quite vast. Apart from that, apart from the vastness, there are also mountains, several important mountains which act as physical barrier. So these mountains they act as physical barrier. Now, I have not discussed in this lecture the concepts of development of monsoon. I would urge you to read those from the DS Lal book, because in this lecture I shall be focusing more on the thermal concept. So, in the thermal concept of the development of monsoon, you have to recall that there is the difference of specific heat capacity between the land and the water body. We all know that water having the highest specific heat capacity warms slowly and cools down slowly, which means that during the summer season, the land heats faster than the adjoining oceans or adjoining seas. Therefore, the lands they encounter low pressure as compared to the adjoining water bodies. Likewise, during the winter season, the land masses they cool quickly as compared to the water bodies. So they encounter high pressure zones as compared to the water bodies, and thus the wind direction reverses as it was there during the summer season. So during summers, the direction of wind normally is from the water bodies towards the landmass, while during winters it is reversed. So this is the thermal concept of the monsoons. So as I had just discussed that one of the most important factor for the development of the uh, m- pressure is the temperature of the Asian landmass. So during summer, if you see this scale, during summer, the Asian landmass it has variable temperature, and during winter it has different temperature. Of course, the variation of temperature will be variable. So during summers, you can see that the landmass in this region over here, it has high temperature. So this is the Himalayan region which has lower temperature. Then here, this is the vicinity of the Lake Baikal and Eastern Siberian region. They have lower temperature. During winter, it's a very interesting phenomena happens. The entire Asian region, which encompasses Russia, Siberia, China, Mongolia, all these regions, the northern Asian part, they develop very high pressure zones because they cool down. So the Asian landmass over here, you can see they have very low temperature. And this extremely low temperature leads to the formation of high pressure zones. So here in the vicinity of Lake Baikal, this is the high pressure zone. So Eastern Siberia, China, Mongolia, all these regions, they have high pressure zones during the winter season. So you can see here that during the winters, this Asian region, it develops high pressure zones, while during the summer seasons it is simply reversed. Now, once the Asian landmass cools to form high pressure zones, then strong anticyclones they develop in this region. Why anticyclones? Because at the center, this is the high pressure zone, so the winds will start going out. So winds start going out means there is the development of a clockwise movement of wind outwards. So this is a strong anticyclone over here. Now the region of the Asian landmass, it develops extremely high pressure due to cooling. But this cooling is also occurring at many other places. This should happen. So, why is it that the Asian landmass develops very high pressure during the winter season? What happens over here is that if you see carefully, this region over here, it is the equatorial region, which definitely is warmer and it is at the low pressure. While in the southern hemisphere, the winter months, like the months of October, November, December, all these months, the winter months in northern hemisphere, they basically are summer months for southern hemisphere. As a result, the Australian landmass, it becomes warm. So it develops again low pressure zone over here. So we saw that the equatorial region has low pressure zone. In the southern hemisphere, it has low pressure zone. So all these adjoining regions, they have low pressure zone. Thus, comparing them, the Asian landmass has the highest pressure, or these are high pressure zones over there. So once the high pressure zones they develop over the Asian landmass, then what will happen? Let me show you in that website. So this is the website for earth.nullschool.net, and I will show you the pressure for the winter months. Let us choose the month of December. So if you see here carefully, well, let it get, yeah. Now, this region over here, this entire region is the Asian uh, region near the Lake Baikal in Siberia. And this is a strong anticyclone developed over here. And the winds, they are being pushed outside. So if you see here carefully, during the winter months, the winds they are going out towards the adjoining regions from the strong anticyclonic zone, which is at a high pressure. So what happens is that these winds, they push the subtropical highs. They push the subtropical highs towards the equatorial region over the Pacific Ocean. This leads to the formation of a semi-permanent low pressure zone over the Pacific Ocean near the Aleutian Islands. So this is the Aleutian Island region. So the winds they push these typically high pressure zones from north towards equator, and this region over here it becomes semi permanent region of the low pressure zone. They are called as Aleutian lows. They are near the Aleutian Islands. So what happens here is that during this time of the year, when the anticyclone develops over the Asian landmass, the winds they start to flow from the Asian landmass towards these Aleutian lows. Okay, so this is one of the uh, impact of the winter cooling of the Asian landmass. Now, from October, yeah. So if we see the now see these wind patterns over here from the high pressure which has developed over the Mongolian and the high Asian region, we can see that these winds they are coming in this fashion. So if you see here carefully, mark the direction of these winds. These winds are blowing from the land towards the sea, and their direction is northeast direction. Now, if you see here carefully also, these winds they flow from Asia towards Japan, towards China, towards Korea, Vietnam. So the winds, since they have developed over the landmass, these winds are cold, dry, and they have no precipitation potential. But these winds are quite stable. These winds are quite stable, and as they move over the China, Japan, they unite with the trade winds now. So if you see here, these are the trade winds. These are the trades. So all these winds coming from the Siberian region, they unite with the trade winds and then they flow in the northeast to southwest direction. But during the summer months, the region which was having anticyclones in the previous case, now all those areas they get dissipated. And if you see here in this animation, see the direction of the wind. In this map, you can see that during the summer months, the land masses they develop the low pressure zones, relative low pressure zones. This is the low pressure zone. And therefore, the winds blowing from high pressure to low pressure. So here it is the low pressure zone. Here it is the high pressure zone over the water bodies. And thus we get the reverse direction of the wind. So now during the summer months, these winds are southwesterly winds, while during winter months, these winds are northeasterly winds. So this is what I was just talking about, that during the winter months, the Siberian region, it develops high pressure zone, and over Pacific Ocean, it is the low pressure zone, because the subtropical highs over here, they are pushed towards the equator. So these Aleutian lows, they cause the formation of cyclones which have anti-clockwise direction, and they lead to the winds flowing from the cold Siberian region, dissipating and coming towards the Indian landmass. Apart from the heating of the Asian landmass, intertropical convergence zone is also very important. So, this is all I had just discussed. That during the winter season, in the vicinity of Lake Baikal, the extremely cold temperatures over there lead to the formation of a high pressure zone. This high pressure zone, it causes these winds to flow outward, and in the Aleutian Island region over here, a low pressure zone is developed. This low pressure zone, it attracts winds from outside and leads to formation of a clockwise cyclone, while over the Siberian region, it is a anti cyclone over there. So if we see the pressure and the wind patterns, so here this is the Aleutian low, and this is the high pressure zone over the Siberian landmass. So you can yourself see how the wind pattern develops during the winter season. During summer season, as I had previously discussed, the entire situation changes. Now, this anticyclone which was over here has dissipated, and several small depressions, take place over there. Then over here, where earlier there was the Aleutian low, now the subtropical highs have come back to their original position. So here, if you see here carefully now, you will find that this region, which was showing the cyclonic movement, has now changed. And we can see the direction of these winds. So this way, they are going outwards. Okay. While over the Asian subcontinent, Asian region, the winds, they are now moving from southwest direction. The winter monsoon winds over the Asian region, they are cold and dry, and they have very less moisture content, because they had developed over here on the landmass. While the summer monsoon winds, they bring moisture from over the water bodies. They have the potential for precipitation, but they can yield precipitation only when they are forced to rise up a geographical barrier like Himalayan mountains, Western Ghats, Annamese highlands in Vietnam, like that. So, this is the general idea about the Asian monsoon in total. Let us now see that the vigor and development of an ideal monsoon circulation in Asia may be attributed to two factors: the vast size of Asian landmass and east west high mountains. So, in the very beginning, as I had told you, that Asian landmass is huge and it has several east west running mountain chains. Now, if we talk about the Asian monsoon, we can divide the Asian monsoon into two. We can divide it into the East Asian monsoon, and the second one is South Asian monsoon. Both of them will have the summer and winter counterparts. So let us again go back to that website and see the wind directions and wind patterns. Okay. The East Asian monsoon, it signifies the wind reversal over China, Korea, Japan, and Taiwan. So it is this region over here which encounters the East Asian monsoon. During the winter season, this area, it receives cold air from Siberian anticyclone. Since the intensity of high pressure over the Central Asia system is very high, so the cold, dry and stable winds, they are more constant. And therefore, in the East Asian monsoon system, the winter monsoon is stronger than summer monsoon. Means the velocity of the winter monsoon winds in the East Asian monsoon system is more than those of the summer monsoon. So if we see here the dates, so in the month of December, if we see here the pressure zones, as I had already explained, now what will happen is that as these winds, they go towards the Japan coast, you can see here that there is quite some distance where these winds may carry some moisture. So, during the winter East Asian monsoon, although these winds have very less potential for precipitation, but the western coast of Japan may receive some amount of rainfall because of the maritime trajectory of these winds. While during the summer season, what happens? During the month of June or July, so we can see here how the temperature patterns have changed now. You can see the temperature has now varied. It has changed during the summer months owing to the specific heat capacity. So what happens over here is that the heating of the continent causes the pressure to become generally low. It causes a shallow depression over the continental interior. Okay. So over here, it becomes now depression, low pressure zone. And these invite the winds towards these low pressure centers. So you can see here that the winds during the summer months are being derived from the Pacific Ocean and the Indian Ocean. Let us put this in a different perspective. So the winds from the Pacific Ocean and Indian Ocean, they both are being dragged towards the Asian region, the East Asian region here. Now, what has happened is that these winds, since they are coming from over the water areas, they bring moisture. They bring moisture. The primary source of precipitation or water during the summer monsoon is the Indian Ocean. There are several people who say that Pacific is the primary source of rain for the East Asian summer monsoon, but it is the Indian Ocean, not the Pacific Ocean. Indian Ocean is the primary source, but the Pacific Ocean, it also provides a significant amount of moisture, because now the depressions which have developed over here, they are inviting these winds from over the Pacific Ocean, which bring in moisture. Also, if you see here carefully, the summer months of the northern hemisphere are winter months for the southern hemisphere. So the Australian landmass, it cools and it develops high pressure zone. So you can see now that these winds, they are blowing from over Australia towards the northern hemisphere. And these winds, as they cross the equator, Ferrell law applies, they turn right, and then they also become one of the reasons for the uh, rainfalls over the Asian landmass. So, what did we understand over here? That the Asian monsoon, it applies the thermal concept, the variation in the heating of land and water bodies owing to their different specific heat capacities brings in either dry winds during the winter season from land towards sea, or warm and moist winds from sea towards land during the summer season. Apart from the pressure and temperature, the land barriers are also very important in monsoonal precipitation. I'll just detour a bit from the East Asian monsoon and tell you what is the importance of these mountain chains. So, in the northern part of India, there is the Himalayan mountain chain which borders the Indian subcontinent in three sides. So, it is a east west running mountain chain. Now, what happens is that during the summer months, and in the peninsular India, there is the Western Ghats. We will come discuss this in detail once we discuss the Indian monsoon. But I am just telling you for the sake that you should understand how important these land barriers are. In the Vietnamese region, there are the Annamese highlands. These mountains are also there. During the summer months, when the moisture laden winds, they try to cross these Western Ghats, they hit them, and since the Western Ghats, they force these moisture laden winds to climb up. So what happens is that they lead to precipitation. Similarly, once these winds, they cross the central Indian portion and they try to climb up the Himalayas, the entire Indo-Gangetic plain receives fair and good amount of rainfall. Same way, when these winds, the southwest monsoon winds, they try to cross these enemies highlands of the Vietnam, then they also lead to the moisture. Apart from it, another important feature of Himalayas is that Himalayas does not allow the cold winds. Himalayas, it doesn't allow the cold winds from the Siberian landmass, which was coming from over there during the winter season. So these are the Siberian cold winds. These Siberian cold winds, they try to penetrate the Indian landmass, but the Himalayas, they prevent these cold winds from coming over the Indian subcontinent. This is the importance of Himalayas, that Himalayas cause the rainfall by trapping or by forcing the southwest monsoon winds. So these are all southwest monsoon winds. They the Himalayas lead to precipitation by forcing these winds to climb up, while they protect the Indian landmass from the cold Siberian winds, which come from the Siberian anticyclone during the winter months. So, apart from monsoonal precipitation, the Himalayas are also very important in protection from these cold winds. All right, so this is the map of the winter monsoon over the Asian landmass. So you can see here the wind direction, wind patterns from land towards the sea. These yellow line, they indicate the convergence zone. So during the winter season, as I had told you previously, the intertropical convergence zone is shifted towards the south. While during the summer season, you can see the summer monsoonal winds, they reverse their direction and they come from the ocean areas towards the land areas. So, to summarize, the summer monsoon of East Asia is weaker than winter monsoon, which we saw. The summer monsoon makes the weather of China and Japan hot and humid. It has high potential for heavy precipitation, while the winter monsoon is cold, dry, and stable, and it has no potential for heavy precipitation. I hope you understood what is the region. Now, let us compare the East Asian monsoon and South Asian monsoon. So, East Asian monsoon lies in the temperate zone, while the South Asian monsoon, it is confined to the tropical zone. The East Asian monsoon is not impacted by any east-west mountain system because there is no east-west mountain system over China and Japan. And what happens over there is that the Siberian anticyclone, it forces its cold winds to penetrate, while the Himalayan and other mountain systems in the north and east of Indian subcontinent, they protect India, Pakistan and Bangladesh from these cold Siberian winds. We had just discussed that due to the proximity of China, Japan, Korea to the Siberian region, the East Asian monsoon is stronger than the summer monsoon. East Asian winter monsoon is stronger than the East Asian summer monsoon. While in case of South Asian monsoon, this is different. Here, the summer monsoon is stronger than the winter monsoon. The focus of the East Asian monsoon lies over the central part of Asia, while this one, this Indian monsoon and the South Asian monsoon, basically we will be discussing about the Indian monsoon over the northwest region of the subcontinent. At the start of the East Asian monsoon is marked by mild weather, while the start of Indian monsoon is characterized by turbulent weather. So let us see these things in the map on that website. So let us compare the East Asian monsoon and the South Asian or basically Indian monsoon. So if you see here carefully, this region over here, Japan, China, Mongolia, this region is the East Asian region. So it lies in the temperate zone, which is very clear. While the Indian monsoon region, it is characterized by the tropical zone over here. Then, due to the absence of any east-west mountain system So in this region, we all know that there is no such facility which will prevent these Siberian winds to come. But here we have the Himalayan mountain belt. Here we have these Vietnamese, Annamese highlands. All these, specifically the Himalayas, it protects India, Pakistan, and Bangladesh from getting invaded by these cold winds. Okay, so you have to understand the importance of these physical barriers. All right, so let us now come to the Indian monsoon. So Indian monsoon is the ideal monsoon where differential heating of land and ocean is subjected to annual latitudinal cycle of the sun as it at its zenith, and it gives rise to immense seasonal wind regimes. The Indian monsoon has a different mechanism from the rest of the Asia. So the East Asian monsoon is completely different from the Indian monsoon. Indian monsoon signifies a marked reversal of the wind direction between summer and winter. So you can see in these pictures. And Himalayas plays a very important role in the Indian monsoonal precipitation. So let us compare the temperature and pressure during the summer season over the Indian subcontinent. So intense heating during summer results in low pressure in the northwest part. So in the Indian subcontinent over here, this region is of low pressure because of extremely high temperature. The ITCZ shifts poleward reaching Himalayas. So the in my previous lectures also I had told you about the ITCZ. Let me just draw it for you. The ITCZ. So around 30-degree north, the ITCZ reaches like this. So this is ITCZ. So since the ITCZ is over here, the winds start converging till this zone. High pressure cells, they develop over the Arabian Sea and Bay of Bengal. So the Indian landmass is so much heated that it has very low pressure as compared to the Arabian Sea and the Bay of Bengal. And therefore, this gives us two branches of the Indian monsoon. Apart from that, as I had also previously discussed, if we look over the temperature of the Indian Ocean region and Australia in the southern hemisphere, we can see here that the Australian landmass, owing to its low temperature, it develops high pressure, and therefore the wind direction is southeasterly. This is how these winds they blow. This is the southeasterly winds. Here in the Arabian Sea, as you saw, already there was low, high pressure zone. So these winds they are already going in this direction. These winds are southwest winds. The winds coming from the Australian landmass, they cross the equator due to Coriolis force, they turn right and they strengthen these southwest winds. So the southeasterly winds, they become now southwest winds. And this southwest winds basically become the southwest monsoon or summer monsoon. So if we see here in this animation, you can see that from over Australia, the winds, so it is a high pressure zone over here. These winds, they are going from the southeast direction. So they start from southeast direction. They cross the equator. Why do they cross the equator? These winds are originating in the southern hemisphere. Why do they cross the equator? Because the low pressure developed over the Indian subcontinent, it is so intense that it attracts these winds. These basically are the trade winds only. These are the trades. But these straits, which had the southeasterly direction, they are attracted by the low pressure zone developed over the Indian subcontinent. Therefore, you can see that as these winds they cross the equator, so this is 0 degree, as they cross the equator, apply the Ferrell's law. Ferrell's law, what does it state? It states that as the winds they cross the equator towards the northern hemisphere, they turn right due to the Coriolis effect. So we can see here that from May end to the first week of June, when this low pressure zones have fully developed, these winds they become very, very intense. So as I was telling you that the Indian monsoon has two branches, the Arabian Sea branch and the Bay of Bengal branch. Let us first look at the Arabian Sea branch. So the Arabian Sea branch, these winds in this picture we saw that over the Arabian Sea, all these winds they are blowing. So these winds from the Arabian Sea they hit the Western Ghats first. So this is the Western Ghat. They hit it perpendicularly at right angles. Now you should understand this, that whenever there is a mountain belt, it has two sides. The direction from which the wind hits it, it is called as the windward side. While the other one, on the other side, it is called as the leeward side. So if a moisture laden wind or a moist wind, it hits the mountain on the windward side, it is forced to rise up. As these winds rise up, they form clouds and they do precipitation. So the Western Ghat region, the western coast, it receives high amount of rainfall. You must have heard that whenever the monsoon it hits India, it first reaches the state of Kerala because of the Western Ghats. It hits the Western Ghats and monsoonal rainfall happens. The leeward side is also called as rain shadow zone because here the wind as it reaches on the leeward side is devoid of rainfall, devoid of its moisture. The second branch is the Bay of Bengal branch. So the Bay of Bengal branch, it has a path like this between Sri Lanka and Burma. As these winds they hit the Arakan mountain belt over here, the same process happens. So in previous case, the Western Ghats and then the Himalayas over here, they cause the precipitation. Similarly, over the Bay of Bengal branch, the Arakan mountains, the windward side receives the highest rain, like this. If we see this animation again, see here carefully that over the Arabian Sea and over the Bay of Bengal, this Bay of Bengal hits the Arakan mountain belt in this region over here, and it leads to the heavy precipitation. But one portion of this Bay of Bengal, BOB, Bay of Bengal branch, it turns and goes towards Assam. We all know that There is a place called as Mausin Ram in Assam, which receives highest amount of rainfall in the world. So, how does that happen? These winds they hit the Arakan mountain belt as well as they recurve and they reach the Assam region. Here in the Mausin Ram, Cherrapunji, they do lot of precipitation. Further, these winds they recurve and then they go like this over here. In case of the Arabian Sea branch, due to the western ghats, these winds they do lot of rainfall over here. But interestingly, if you read about the Western Ghats, you will find that the height of Western Ghats in the northern region is lower and in the southern region it is more. So these portions, the northern part of the Western Ghats, they receive more rainfall than the southern parts in the leeward side. You should understand this that if the mountain they have more height, they will cause the winds to rise up more and winds will tend to lose all their moisture. So there will be a heavy difference between the amount of precipitation on the windward side and the leeward side. But when the height of mountains is lower, they are narrow belt, then the difference between the windward and leeward side is not much. As they cross this, some portion of these moisture laden winds from the Arabian Sea, it goes towards Rajasthan. And then, since over Rajasthan there is no such physical barrier, so these winds they do not cause precipitation. The region for the desert over here is that the winds which pass from over here they do not have any physical barrier to stop them, and therefore these moisture laden winds they pass and they go up to Kashmir. So this portion over here it lacks rainfall. If you remember the Hadley cell, 25 to 30-degree north and south latitudes are those zones where the sinking arm of Hadley cell exists. So the sinking arm is having the air which is cold and dry and therefore no precipitation. But during the uh, summer monsoon, also these winds coming from Arabian Sea, they pass through the Rajasthan because there is no such physical barrier which could stop them. Therefore, it remains a desert. So I hope you understood this basic idea about the summer monsoon. So if we try to draw both the branches of summer monsoon, so this is the Arabian Sea branch, while this is the Bay of Bengal branch. And I have tried to explain to you how their mechanism functions. Now, during the winter season, what happens? You can see there is a drastic change in the temperature and pressure as compared to the summer. Now, over the Indian subcontinent, Indian landmass, due to low temperature, high pressure zones develop, and in comparison to that, the water bodies they have these low pressure zones. So, what happens over here is that these winds they change their direction. So now during this portion of the year, during this time of the year, during the winter season, the high pressure zone over here, low pressure zone over here, it leads to the outflow of these winds. These winds They are northeasterly in direction and they go towards the southwest. The northeasterly winds, since they originate on these landmass over here, they are cold and dry and they have almost no potential for rainfall. But yes, the winter monsoon is a cause for rainfall over the eastern coastal region as well as some parts of central India as well. The moisture which is brought about by these winds, it sometimes, if they get a maritime trajectory, then they lead to the rainfall over the some portions of the Indian subcontinent. So this was all the basic idea about the monsoons. To summarize all these, first of all, we have to understand that monsoons are basically the seasonal reversal of wind patterns. The best concept to study these monsoons is the thermal concept, wherein you have to keep in mind the differential heating of the landmass and the water bodies, the adjoining oceans and seas. The physical barriers like east-west running mountain chains also play a very important region in they have a very important role in the monsoonal precipitation. Apart from these temperature, the ITCZ migration also plays a significant role in the monsoons. The monsoons can be classified as the East Asian monsoon and South Asian monsoon. So, South Asian monsoon is basically represented by the Indian monsoon. The East Asian monsoon is restricted to the temperate regions and it impacts the countries like Japan, China, Vietnam, Korea. While the Indian monsoon, it impacts countries like India, Pakistan, Bangladesh, and then Myanmar. The East Asian winter monsoon is stronger than the East Asian summer monsoon, while the Indian summer monsoon is stronger than the Indian winter monsoon. But one thing is common in both the East Asian monsoon and the Indian monsoon. They both have the direction of the winds during summers from the ocean towards the land or from ocean towards the land, and therefore the summer monsoons, they bring in moisture and warm winds, while during the winter seasons they are invaded by cold and dry winds. So this is all about the monsoonal patterns. Several questions are asked about this topic in the net examination. Try to read it from DS Lal and a few other sources. There are a lot of things which I have skipped because I think they are not very important from the examination perspective. In the next lecture about monsoon, I shall discuss the factors that impact or control the Indian monsoon. Phenomena like El Nino, Indian Ocean dipole, how they impact the Indian monsoon, we shall discuss in the next class. Till then, keep reading, develop concept, and stay safe. Thank you.